So when we're solving log equations, there's two different scenarios. The first scenario is when a log equals another log. And in this case, what we want to do is we want to make sure that all the logs in the equation have the same base. So once you look at the equation, once you make sure that all the logs have the same base, then what you want to do is you want to condense left and right side down to one log. So once you get one log equal to another log, you're going to set the arguments equal to each other. Then solve for the variable. And the pain in this process is after you get your values for the variable, you have to check for extraneous solutions. You have to check for solutions that do not work out. And just a quick reminder, remember, arguments cannot be negative. So that's the first scenario where a log is equal to another log. There's another scenario when a log equals a whole number. So when a log is equal to a number, not a log equaling another log. Once again, we want to make sure all logs have the same base. We are going to condense to one log. And then after you condense to one log, what you want to do is you want to isolate the log. The log with its argument. And then after we condense the log down to one log with its argument, what we want to do is rewrite as an exponential. We're then going to solve the equation. And we still have to check all solutions. right, let's do some examples. So we have log base 3 of 2 plus 2 log base 3 of x is equal to log base 3 of 7x minus 3. So no matter which type of equation we have, our first step is to make sure that all of our bases are the same, because when our bases are different, it's going to be a completely different process. Are all of our bases on these logs the same? Yes. Now, is this log equals a number or log equals another log? This is log equals another log. When it's log equals another log, what we want to do is we want to condense down to a log, one log on the left and one log on the right. The log on the right is already set for us, right? Log base 3 of 7x minus 3, we're good. We have our log, our base, and our argument. On the left side, we need to condense this down to one log. So the first thing I'm going to do is take this 2, put it back as an exponent. So this is log base 3 of 2 plus log base 3 of x squared. Now we have log addition. What can I change that back into? Multiplication. So I'm now able to pull out 1 log base 3, and this is going to be 2 times x squared. At this step, I have 1 log on the left, 1 log on the right. We have the arguments here. Now, this is log base 3 of this is equal to log base 3 of this. Because they're both the same log with the same base, can I now just set their arguments equal to each other? That's what we're going to do. Since the left has to equal the right and they have the same base, we will set them equal. So we're going to say 2x squared plus 7x minus 3 is equal to 0. Oh, sorry. It's not equal to 0. 2x squared is equal to 7x minus 3. What am I going to have to do here? Set it equal to 0 so we can do what? Factor. So we're going to subtract the 7x squared. I'm sorry, the 7x. We're going to add the 3. And now it's set equal to 0. Now we factor. So we're going to have a 2x and an x. We know both our signs are going to be negative. And I'll put the 3 here and the 1 here. When we solve, we're going to get 2x minus 1 equals 0. X minus 3 is equal to 0. We will get 2x equals 1, so x will equal a half. And here we get x is equal to 3. We have to check for solutions that don't work. So how do we check? We have to go back to the original, the very first one, before we changed anything. So I'm going to first check x equals a half. And I'm going to have log base 3 of 2 plus 2 log base 3 of x is equal to log base 3 of 7x minus 3. Now I'm going to plug in the half for any time I see x. So this is log base 3 of 2 plus log base 3 of a half, and I'm going to pull that exponent up to x squared, equals log base 3 of 7 times a half minus 3. So now we are log base 3 of 2 plus log base 3 of 1/4 equals log base 3 of 7/2. Do you guys agree 7/2 is 3.5? Yeah. Minus 3. All right, let's keep going. Now I'm going to pull this into one log. So this is log base 3 of 2 times 1/4 equals log base 3 of a half. Well, what's 2 times a fourth? A half. So this is log base 3 of a half equals log base 3 of a half. Did this check? Yes. Left equals right. We are good. I'm not done. What else do I have to check? The 3. So now we're going to check x equals 3. So here we're going to have log base 3 of 2 plus 2 log base 3 of 3 equals log base 3 of 7 times 3 minus 3. I'm going to bring that 2 over up top. So log base 3 of 2 plus log base 3 of 3 squared equals log base 3 of 18. I'm going to pull this into one log on the left. Log base 3 of 2 times 3 squared, well 3 squared is 9, equals log base 3 of 18. Are these the same? Yes, so both our answers checked. All right, let's do another one. So we have two options here, log equals log or log equals number. Which one is this? Log equals number. So our game plan for this is different than when it's log equals log. We still want to make sure that we have all the same bases on the logs, which we do. We have a base of 2. On the left side, I'm going to condense this down to 1 log. When I condense it down, it's going to be log base 2, and I'm going to have x times the quantity of x minus 4 equals 5. I turn the log addition into multiplication. I'm going to now distribute in that x, so now I am log base 2 of x squared minus 4x equals 5. We cannot set this argument equal to 5. Because in the other problem, it was log base 2 of an argument equals log base 2 of an argument. So it's saying the left side and the right side are equaling each other, and they were both log base 2, which means their arguments had to match. But this is different. This is saying this log equals this whole number, not another log. So we cannot set this equal to each other. We now have to turn this back into exponential. Now remember, when you have a log, it's log base, our argument, is our answer, and that equals the exponent. So knowing that log base answer equals exponent, can we change this back into exponential? Absolutely. So what's it going to be? 2 to what power? To the 5th power is equal to x squared minus 4x. Well, what's 2 to the 5th power? 32. So now we're going to have 32 is equal to x squared minus 4x. We're going to have to factor, so set it equal to 0. X squared minus 4x minus 32 equals 0. When you factor, you're going to get x minus 8 and an x plus 4. X equals positive 8 and x equals negative 4. Now we need to check. So I'm going to check x equals negative 4 first. So when I go to write this out, log base 2 of -4. I am stopping right there. I do not need to go any further. Why? You can't have a negative argument. This is undefined. We can't have a negative argument. So what does that mean right away? -4 is rejected. Now we're going to check 8. So we go back to our original log base 2 of 8 plus log base 2 of 4 equals 5. We could just even solve this. Isn't this log base 2 of 2 to the third plus log base 2 of 2 to the second? So remember the shortcut? What is this going to be? 3. What's this going to be? 2. And 3 plus 2 is equal to 5, so that works out. Hey, if you did it the other way, if you changed it to multiplication, you'd have log base 2 of 8 times 4 equals 5. So this is log base 2 of 32 equals 5. And what is this? This is 2 to what power gives us 32? 5. So it still works out. Thank you. This is like the third delivery of tissues and markers I've gotten today, but I'll take them.
Sell them to the other teachers.
I could potentially do that.
Mr. Rose, oh my God. Please do.
All right, let's keep going. This is the main concept. Now it's just practice. There's really not much more to it. You need to get more paper. We don't let ln scare us. What is ln? Log base e. If it helps, you write log base e, if that makes you feel better. Is this log equals number or log equals log? Log equals log. So when we have log equals log, we condense it down to 1 log on each side, and then we set the arguments equal. We are already down to 1 log on each side. I'm just going to recommend we do one thing. What do you think I'm going to recommend we do? Yep, make the 2 an exponent. So this is log base e of x squared equals log base e of 25. Can I now set the arguments equal? Absolutely. X squared equals 25. X will equal plus or minus 5. Will either of these get rejected? The -5, exactly. So X will just equal 5.
Is it possible I'd like to know solutions?
It's possible, yeah.
Negatives will always get rejected, right?
No. That's a great question. Let me show you why. I'll show you one where it wouldn't.
Where it's not the argument.
Exactly, where x is not the argument. So let me show you one. So let's say we have log of 2x plus 30 equals 1. There's no base written. When there's no base written, what's implied? It's a base of 10. Excellent. Is this already in a good format for us? Yeah, we're down to 1 log, but it's not log equals log. So I can't do 2x plus 30 equals 1. This is log equals number. When it's logs equals number, what do we have to do? Change it to exponential. So this is log base 10. So remember, it's log base answer equals exponent. So what does this mean? It's 10 to what power? Equals 2x plus 30. So we have 10 is equal to 2x plus 30. Now we solve, and we are going to get x is equal to negative 10. This is not going to be rejected. Why is this not going to be rejected? Because x is not our argument. What is our argument? No, it's not 10.
2x plus
The whole quantity of 2x plus 30 is our argument. So when we plug that in, log base 10 of 2x plus 30 equals 1, we're going to say log base 10 of 2 times negative 10 plus 30. So this is log base 10 of 10 equals 1. Well, 10 to what power gives us 10? 1 equals 1. It works out. Am I going too fast for you all? No? Okay. I'll give you, we have 3 more problems. Where am I with time? What time is it? We have time. Okay. So I'll give you 1 to try on your own, and then we'll do 2 more problems together, and then we'll call it a day. All right, who has an answer for me? X is equal to what? David? 6. Who needs to see me do it? Nobody? Okay, great. 2 more. Okay, so we want it down to 1 log. Do we have it down to 1 log? Yeah. Now, what we also want, this is log equals number. So we can't just try to set the arguments equal to each other because there's no argument here. There's no log here. So log equals number means we want to change it back to exponential. Before we could change it back to exponential, we need to get the log and the argument by itself. I can't have a number in front. I can't have a number behind it. The argument is 11x minus 12. This plus 1 is not part of the argument. So my goal is to get log of 11x minus 12 by itself. Everything else has to move to the other side. How do you think we're going to move things to the other side? Good. I'm going to subtract that 1. So now we have 2 times the log of 11x minus 12 equals 2. What do you think I'm going to do now?
Can't you make it an exponent?
We don't want to bring it to an exponent, no. We would have brought it into an exponent if it logs equals log. That would have been helpful. But do you really want to be squaring 11x minus 12? You don't want to do that. So what can I do if I'm just trying to think equation, if I'm trying to isolate the log? Divide it. Isn't this 2 times the log of that? So I'm going to opt to divide it out. So now I have log of 11x minus 12 is equal to 1. Can I now change it back to exponential? Yeah, so it's going to be 10 to the first power is equal to 11x minus 12. So now, add that 12 over. So we have 22 is equal to 11x, so x is equal to 2. The check works. All right, last problem. Okay, so this is log equals number. So we're going to have to change it back to exponential. Before we change it back to exponential, what must I do? Condense it. You got it. We need to condense this down to 1 log. They both have the same base, so it's not going to be too bad. I have log subtraction. What does that turn into? Division. So I'm going to pull out 1 log base 2, and this is going to be 15x minus 1 over x minus 1 equals 4. Am I down to just a log and its argument on the left side? Yeah, so now we change it back to exponential. So this is going to be 2 to the 4th power is equal to our argument, which is 15x minus 1 over x minus 1. 2 to the 4th power is 16. What should I do to solve this? Multiply by x minus 1 on both sides. So that x minus 1's cancel, and I have to distribute in the 16. So this is going to be 16x minus 16 equals 15x minus 1. When we solve this, we're going to get x is equal to 15, and I will tell you the check works. All right, we're done.